Good morning. My name is Toby, and I'm with Terrace Technologies. This morning I've got a RTToolBox simulation, and we're looking at the pallet command. I have made up a little end effector that's picking up 4 pieces and then placing it in a pallet. So if you imagine it going down a line, populating the 4 pieces and then starting in a pallet and then 1, 2, 3, 4 across. And it's a 10 by 10, so it'll move 10 times. Just to give you an idea, so that's a weight slot. It's picking it up. It actually picked up twice. Now it's going over moving. Now it's dropping in the pallet. Picking up again, dropping in the pallet. It actually didn't pick up twice. It wouldn't put my buffer in because I have a buffer in it, but every time it's coming over this way, it's putting it into a pallet. If you picture a pallet here, and we're doing 4 at a time with a 10 by 10 position. So I'm going to bring this up. This is the program right here, or actually it already passed through it. But when it gets back to the PLT command, it's populating the pallet position for the 10 by 10 for the 10 by 10 tray that it's loading. So what I wanted to do is have people understand the pallet command, or the pallet function that's built into the Malfa basic code. For instance, I'm defining 2 pallets here, or in this case they're trays, but a pallet could be defined, we have a 10 by 10 section, so 1, 2, 3, dot, 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 10, and then 10 this way, and the robot is moving from this position to here, and then that way, and this is what they call the zigzag, and it will go through that based on the positions that you define. And then this is the 10 by 10 by 1, and I'm initializing it for, or initialization may not be the correct way of saying it. We're defining position P50, but we're changing P20 and P30 within the XY coordinate system every time. So we're telling the robot to change the XY for the next position that it goes to every time, so that it, position 1, position 2, position 3, etc. And if you need more information on where to get this at, if you're in RTTool, the help function, you can pull up PLT, and it goes through the definition and how they define their function block, and goes through a 3-point pallet and a 4-point pallet. What they mean by that is just that you'll use 1, 2, 3 positions, or you will use 1, 2, 3, 4 positions to define it. You get more accuracy with a 4-point than you do a 3-point. And then that's what they're going through here. You've got these kind of options let's say 1, 2, 3, 4, 5, 6, basically 6 options to set up your grid. And this is also in this definition reference in the help function. So if we go back here and look at that, then you've got an example program that you can run, and you're looping through for the definition, and then you are also doing a hand open or a hand close, depending on if you're doing pick or place. So this is a built-in functionality that's in the Malfa basic. You're gonna find it in probably every robot program or environment that's out there, and it makes picking places easier. That way you don't have to do all the math or define every single position in your pallet to get the robot to pick and place to it. So it saves you time, and something that you should understand if you're doing pick and places. Enjoy, and if you want more information on Mitsubishi, you can go to Mitsubishi Electric and choose your region, and if you log into their help area, then you can get documentation on pretty much anything that you want to research, and they have plenty of documentation for programming robots or controllers or anything that you want to get assistance on for how would you call it, Mitsubishi products, and even with RTTool and Malfa, if we plug in RTTool, it has a user manual for the RTTool. I'm using RTTool 2, they are up to RTTool 3, and you can find, let's see, there we go. So it'll tell you everything that you need to know as far as setting up simulation in RTTool. From what I understand, RTTool 2 is not, it's the same software environment in RTTool 3. They just added more functionality in 3 for simulation, and then also creating the environments so that you can simulate better before you download to the robot controller. And that's the beauty of RTTool. If you notice, like I'm in simulation mode right now, but I have an offline mode and an online mode, and so I can program in the offline program and then use my program manager to download to my simulated robot. It works the same way when you are connected to a live robot, but if you set up your simulation properly, then you can create your environment here before going live and verify your program. Now granted, your accuracy in here will be off unless you pull in your AutoCAD drawings or your CAD drawings to create the environment as closely as possible for your physical environment. So in this case, I didn't have any of that information when I built this, and my physical environment was different, and I had put in some funky locations to get the algorithm down, and then my palletization actually didn't work when I went live, so I had to adjust to that. that just goes to show that you need to do your mechanics and your electrical drawings ahead of time if you want your simulations to work. But the point is that RT Toolbox 2 has the capacity, Toolbox 3 also has the capacity, and it's a very versatile tool for programming Mitsubishi. Enjoy!